before joining the ICR system. His research interest includes climate change, dairy industry, and impact assessment modeling. He has around 26 research papers published in reputed journals, ERA, EPW, Journal of Dairy Research, Theoretical and Applied Climatology, Environment Development and Sustainability, along with 5 international research papers. So he, as I was just mentioning, he has learned this methodology, two-stage least square regression analysis from Dr. Smita Sirohi, who was his guide. So all of you must be knowing about her. She is gem in econometrics techniques. With that, I would just like to invite Dr. Vishwa for his lecture. So we are grateful to you because in spite of your bad health at the moment due to COVID and election duty and all, you you're taking this lecture and for the benefit of participants. So we are really thankful to you, Dr. Vishwa. So
thank you, ma'am.
Now you may continue with your lecture.
Oh, thank you, ma'am. So good morning to all the participants. I have been told that many of the participants are faculties and scientists in the agriculture universities and ICR institutes. So I'm quite sure that this topic, that is the two-stage least square regression analysis, is should not be a new technique for all of you. But at this stage, since this topic has been allocated to me for discussion with you, so I will be very brief, but I will focus more on the hands-on training, because it is very important that merely the knowing the theory of many things will not work unless and until you know how to handle it practically, or at the present time. To handle it is some modern software. It is very important. So I have tried to make my lecture as simple as possible, because this topic is a little bit complex. If you will go through any standard book, like the basic book is Gujarati, and some other books is Green and Madala. They have written it in very complex language, not complex, very standard language. But I have tried to simplify the things so that it will be understandable. It is very easy to understand the crux of the topics. That is very important. Then after I will also suggest to refer some good books if you are willing to go in details. So let's start. You know that the regression analysis for estimating any regression analysis, the OLS is the very important and most popular technique. And if the regression analysis assumes that there is a universal relation between Y and X, that is when you are expecting that your Y is influenced by a number of explanatory variables and some of the error term, then the OLS is the very popular technique. I have tried to represent it in this figure, that is X is influencing Y, and some of the error term is also influencing Y. If this situation prevails, then obviously you are going to apply OLS. Among the various assumptions of OLS, you may remember that there is 8 to 9 or 10 assumptions of conducting OLS. Two important assumptions are X is your explanatory variable is non-stochastic. What do you mean by non-stochastic? Non-stochastic means it is fixed in random sampling. And the correlation between X and U, that is the covariance between X and your error term, is 0. If this situation, these two condition is one of the important condition for conducting OLS for regression analysis. Now imagine if we are doing field experiment, then it is in our hand, it is in our control to keep your X variable fixed in repeated sampling. But in social science research, we may face many situations when there is reverse causation. That means to say X is influencing Y and itself influenced by Y. And there may be a situation when your error term is you're affecting the X variable. If this situation prevails, then it will violate the two assumption which I have mentioned earlier. In this case, like Y is your endogenous variable, your X also becomes endogenous variables, right? That is, X is not more non-stochastic. It will become a stochastic, that is random. And if this condition prevail, then the covariance between X and U will not equal to 0. That is, X and your explanatory variable and your error term will be correlated. So obviously, when these two assumptions of OLS is violated, then your OLS estimates will be not unbiased. In other words, it will be biased, and as well as it will be inconsistent. Then you cannot rely on your OLS estimate. And econometrics suggests that when this condition prevails, then it is better to lump together the set of variables that can be determined simultaneously by the remaining set of variables. Example means, in other words, you see, I have written one example, that is Y2 is influenced by the Y21 and X1 is explanatory variable. In this, you can say, if you feel that Y2 is influenced, Y2 is endogenous, then we have written another equations in which we have taken all the endogenous variable together along with the explanatory variables. And we have made a system of equation, and this system of equation is nothing but called simultaneous equation model. A model that, that represent the system of equations containing all endogenous as well as explanatory variable. If you have any doubt till that, you can ask me. Now, let's see some practical examples. In the very popular practical examples of simultaneous equation model is the demand and supply function. We know that the demand function and supply function, a quantity demanded and the price determined in the market is influenced by the system of demand and supply function. Now, I cannot use blackboard, so I will request you to just imagine what I am going to say in my next few lines. Now, you just imagine the equilibrium quantity and equilibrium price, that is determined by the intersection of your demand and supply function. Now, let's imagine if U changes. What is U here? What is U here? That is any factor that change your quantity demanded. Suppose, let's say it is a income. Now, if income increases, then definitely your quantity demanded will increase. The basic microeconomic theory says that if income increases, it will shift upward the demand function. When the demand function is shift upward, then obviously your quantity demanded and price, the equivalent price will change. That means to say your error term has the influence on your explanatory variable. That means to say that the correlation between your explanatory variables and your error term is not zero, it is correlated. And once it is correlated, it has violated the OLS assumption. Similarly, in the supply function, if UT, what is supply function is, I have written that supply function is quantity supplied is determined by price and error term. Error term maybe here is the factor prices. Now suppose if factor prices increases, it will the shift supply curve upward, and if factor prices decreases, it will shift the supply curve downward, right? And if this will change, if this will increase or decrease, the quantity demanded and equilibrium price, quantity supplied and equilibrium price will automatically change. So again here, the error term has influence on the equilibrium price. So this P and UT is correlated. That is, covariance between your explanatory variables and your error term is not equal to zero. It has violated the condition of OLS. So we can say that P is your endogenous variable. right? The second example I have taken, that the consumption function in income identity. If you remember your macroeconomics theory, the very good example of the Keynesian income function, your Keynesian model, that is the consumption function is CT is equal to beta 0 plus beta 1 YT plus UT, where beta 1 is your marginal propensity to consume. Now, income identity is given by YT equal to CT plus IT. You can see very clearly that your YT is influencing CT and itself influenced by CT. This is the system of simultaneous equation. That is, one your explanatory variable is influenced by your dependent variable and itself influencing your dependent variable. So if this system prevails, then we cannot apply OLS for estimating these equations, and therefore we have to look for another econometric techniques which will be suitable, which is very suitable for estimating this type of equations if we face. Now, sometimes if you are it is very important to understand, particularly if you are a faculty in an agriculture university, you will often face the mathematical proof that covariance of X and like what I am telling, that why it has violated the OLS assumption. Which assumption? That is covariant of X and your explanatory variable and your error term is not equal to 0. How? It is very important to understand how, if there is simultaneity exists between the model or between the variables, then why covariance of X and U is not equal to 0. I am using this slide because it is not a very tough mathematics. It is very simple with example, or while taking very simple algebraic alterations, I will prove that when the simultaneous equation condition exists, then how it violate your OLS assumption. I have taken the example of consumption function where CT equal to beta 0 plus beta 1 YT plus UT. I have considered it equation 1, and income identity is YT equal to CT plus IT. IT is investment, CT is your consumption, and YT is your income. You know that is, I have written equal to ST, that means investment equal to saving. That is a simple macroeconomic theory. Now what I did, I will substitute the consumption function CT in this equation. That is, we have substituted equation 1 into equation 2, and then we can write that YT equal to beta 0 plus beta 1 YT plus UT plus IT. Very simple mathematics. Now, what I will do, I will take this parameter. Is it visible? Where I'm sliding my cursor, beta 1 YT. I will take beta 1 YT on the left hand side, that is YT minus beta 1 YT, and the remaining part will be on the left hand side. And taking YT in common, then you will have 1 minus beta 1 with you, and just shift the 1 minus beta 1 on the right hand side, you will get this equation. And now taking the expectation value, that is mean value, that is expected value of Y, and is equal to it is a simple your econometrics knowledge, that is expected value of Y equal to expected value of beta 0 plus 1 minus beta t. Why? Because expected value of beta 0 is always beta 0. So this will be same, that is beta 0 plus beta 1 plus IT divided by 1 minus beta 1, and importantly, very importantly, this term equal to 0 because the expected value of UT equal to 0. So this term will become 0. Now, when you take the difference, it will give YT minus E minus YT. That I have written here, YT minus expected value of YT. Now this term will cancel out, this term will cancel out, and only this term will remain, that is UT by 1 minus beta 1. It is YT minus expected value of YT is equal to UT by 1 minus beta t. Now, when we take the covariance of YT and UT, what is YT here? Here YT is our explanatory variable. YT is our explanatory variable. So covariance of YT and UTs can be written as expected value of YT minus expected value of YT. into ut minus expected value of ut. This is the basic econometrics theory. How to write covariance of yt and ut in econometrics theory. If you will open the page of first and second chapter of your econometrics, the basic econometrics, you will get this type of basic formulations of this covariance of yt and ut. So we have derived that yt minus expected value of yt is equal to ut minus 1 by beta 1. So if you write this value and expected value of ut is again equal to 0, then we have only ut and ut.
Dr. Vishwa, you can make your presentation in full slide mode because many are watching it through mobile. So
okay, ma'am, is it slide is not
okay? You can unshare and share it again. Sometimes that happens. Now make it in full slide mode.
Is it visible, ma'am?
Yes. Yes.
Okay. So I was here. So just with this little mathematical modification, we have come to the point that covariance of yt and your ut is equal to expected value of ut square by 1 minus beta 1, and expected value of ut square, that is expected value of error term, is nothing but the variance, and you know that variance cannot be 0. Variance, the term variance will never equal to 0. So mathematically we have proved that this situation exists, that is, if the simultaneous relation between the equation exists, then the covariance of your explanatory variables and your error term will not equal to 0. That means to say, when this type of situation exists, then it is not advisable and it is not correct to use ordinary least square technique for estimating this type of equations. Now, before moving ahead, it is very important to understand two important definition. That is, one is a structural equation and reduced form equation. A structural equation is one which represent the whole equation or whole true economic that is the economic model, true economic model or behavior of an economic agent, that is consumer producer. Like in a previous example, this whole system, that is Keynesian model, is represent the true economic system, the actual economic system. And this, when we write the actual economic behavior or system in the functional form, then it will is a behavioral equation or a structural equations, and the coefficient is known as the structural coefficients. Now, just remember our previous example with mathematical modifications. What I had did, that we have converted this equations into yt equal to beta 1 0 beta 1 by t by 1 minus beta 1 it it. This equation you have remembered. Just I have written this. And I have considered beta 0 minus 1 by b1 equal to pi 0. This one I have taken pi 1, and this error term I have written wt. What I did here, if you see carefully, I have explained all the endogenous variables, that is yt, in the terms of explanatory variables. Here in this function, it is all the true equation, true functions representing the economic situation or the economic model. Now, in this reduced form equation, what I did, I have taken all the endogenous variables as a dependent variable and converted or regressed it in the form of explanatory variable. If you are able to do that, then this new set of equation is called reduced form equation. That is, expresses an endogenous variable solely in terms of predetermined variables and the stochastic disturbance. Okay, now if you can see, now we can apply the OLS regression on this equation. We can get pi 0, we can get pi 1 hat, and from pi 0 hat, we can get beta 0, beta 1, and from pi 1 hat, we will get beta 1 with little mathematical calculation. And if you know well, that when we use this type of system, it is popularly known as indirect least square technique. So I will use this terms in our another slides. So I have explained it here. Now, before moving ahead, if there is a simultaneous relation exists between the equations or in the system or in the model, if there are two or more equations which are in the simultaneous relationship, it is very important to identify the equations before applying or before choosing the appropriate technique, because there may be different type of simultaneous equations, and for the different types there are different suggested methodologies. So identification problem state that where numerical estimate of the parameters of structural equations, remember the structural equations can be obtained from the estimated reduced form coefficients. I will go back. It means that whether you are able to derive your beta 0 from pi 0, whether your identification problem says that whether you are able to obtain beta 1 with your pi 1. If yes, then your equation is identified. If no, then your equation is unidentified or under-identified. And if yes, that is, if your equation is identified, it has two cases, that is exactly identified and over-identified. If you are able to get unique value of the structural parameters, again I will go back. If you are able to give only to get only one value of beta 0 from pi 0, then this is the case of exactly identified. If you are getting unique, sorry, I have mistaken here. The same thing I have written, but I will correct here. Over-identified is the case if more than one numerical values you are obtaining, then it is the case of over-identification. Exactly identified is the case if only one numerical value obtained, then it is the case of exactly identified. If more than one numerical value is obtained, then it is the case of over-identified. Now, here I will restrict myself here only because there is a lots of discussion on the identification problem in the book. But my point is actually I will be willing to I have to deal with the 2SLS case, and my point is I have to before choosing the 2SLS, we should be able to identify our our equation, because 2SLS is the technique which is only applied for the over-identified, which is best suitable for the over-identified equation. So you must be able to identify that your equation in which case you are going to apply 2SLS. So that's why I have used this presentation here. Now, for the identification, there are several rules as have been suggested in the books. That is called the order condition of identification and rank condition of identification. These are different, very long. It will take very long time for discuss all the things. But for the simplicity, I have written the order condition of identification for this, and it states that in a model of M simultaneous equation, in order for an equation to be identified, it must exclude at least M-1 variables, endogenous as well as predetermined, appearing in the model. If it excludes exactly M-1 variables, the equation is just identified. If it excludes more than one minus variable, it is over-identified. Now you will understand more clearly with example. Let's see this example. Example number 1. This is the demand function. This is the supply function. Demand function I have written like that, and supply function is Qt equal to beta 0 plus beta 1 Pt plus Ut. Now you see what is the M here? What I have given in a model of M simultaneous equation. So what is the M? M is equal to 2. There is 2 simultaneous equation. Okay. So in order to identify this equation, each equations must exclude M-1 variable. That means to say M-1 endogenous as well as exogenous variable. Now you see, it is the demand function and it is the supply function. the demand function has, first see what are the endogenous and what are the exogenous variable in this model. You see Qt and your Pt is your endogenous variable, right? And your It is your exogenous or predetermined variable. Sorry. In supply function, Qt and Pt is your endogenous variable. Now, there are two endogenous variables in the whole system, that is Qt and Pt, and one predetermined variable, that is It. Now you see the demand function has Qt, Pt, and It. That means to say it has not excluded any any of the exogenous or endogenous variable, right? If it has not excluded any variables, then this means the demand function is unidentified. But if you will see the supply function, it has excluded one exogenous variable, because I have written here in the previous slide, it must exclude at least m-1 variables, endogenous as well as predetermined, that is exogenous. Now, so our supply function has excluded one variable. Which variable? That is investment, IT. So our supply function has excluded one exogenous variable, that is IT. So we can say, since our m is equal to 2 and 2 minus 1 equal to 1, that is, this had excluded one variable. So supply function is exactly identified or just identified. Now, I will request our participants to identify the example number 2, that is demand function and supply function. First, tell me what is the number of M? What is the number of M here? Please participate, because otherwise it will not be useful for you, because it is a basic thing. Unless and until you will participate in the discussion, it will not going to help you. It is simply with the waste of time. What is M here? M is equal to 2. That is the system of M simultaneous equation. M is equal to 2. And what are our endogenous variables? What are the endogenous variables in this example 2? That is, in this simultaneous equation model, what are the endogenous variables? That is Qt and Pt. And what are the exogenous variable? Your IT and Pt minus 1, that is this variable, that is price of the previous year. And you know that price of the previous year is well known to you. Last year prices is well known to anyone. So this is treated as exogenous variable, that is last year previous year price. So now if you will see the demand function, so it has included in itself Qt, Pt, It, but it has excluded one variable, Pt minus 1. So in the 2 system of equation, it has excluded one variable. So this function is demand function is just identified. And in the same way, the supply function, which has Qt, Pt, and Pt minus 1, but it has excluded one variable, that is It. So this function is also just identified. Very interestingly, if you will go for example 3, now you see your M is equal to again 2, but your exogenous variables, your exogenous variable are now IT, RT, this is RT, this is IT, and this is PT minus 1. Now you have 3 exogenous variable. Okay, and 2 endogenous variable, that is Qt and Pt. This is the 2 endogenous variable and 3 exogenous variable. Now, if you will see the demand function, now the demand function has Qt in itself, Pt is there, It is there, RT is there. So how many variables? If there is any variable, if you can find out that it has excluded, yes, it has excluded one variable, that is Pt minus 1. So again, the demand function is just identified because the system of equation is 2 and it has excluded one variable. So this is the demand function is just identified. But if you look at the supply function now, if the supply function has excluded 2 variables, that is IT and RT, That means to say it has excluded more than m-1 variables, endogenous as well as exogenous variables. And if this is the case, then the supply function is over-identified. The supply function is over-identified. And for this supply function, it is the case where we are actually using two-stage least square technique. Okay. If you have any problem till this slide, you can ask me, because gradually we are moving to the practical part. If you have any condition in identification problem, then we can discuss again. Otherwise, I will go. Okay. Now, the method of two-stage least square that I have previously mentioned, it is especially designed for over-identified equations. Like in this situation, what you see, your equation 2 is over-identified because your y1t, y2t is your endogenous variables, and x1, x2 is your exogenous variables. And the equation 2 will have not included the two exogenous variables, that is x1 1t and x2 2t in its system. Therefore, these had excluded two variables, so it is the over-identified model, over-identified equations. And for this type of equations, we are using two-stage least square technique. So if this is the case, you know that y1t is endogenous variable here. So we know that if it is endogenous variables, then it is correlated with your error term, that is your disturbance term u2t. Now, what is the ideal solution? What we are expected to do, that we will search for any other variables or list of variables that can be used as the proxy for this y1t. If you are able to search that, if you have any variables which can be used as a proxy for y1t, which is very much similar to the y1t in its properties, but at the same time it must not be correlated with your disturbance term. If we are able to do that, then we can run OLS on this technique. Now the problem is how to search this type of variables which are very much we are proxy to the y1t, but at the same time it should not be related with u2t. And this problem is solved by the technique of two-stage least square. The basic idea behind 2SLS is to replace the stochastic explanatory variable, that is y1t, by a linear combination of the predetermined variables in the model and use this combination as the explanatory variables. The 2SLS method thus resembles the instrument variable. That proxy variables is instrument variable method of estimation, in that the linear combination of the predetermined variables serve as the instrument or proxy for the endogenous regressor, that is y1t. Now I will demonstrate here the method of OLS. Now just listen this. Just see this equation once more. What I have, the system y1t equal to beta 01, beta 11, y2t, x1t and x2t, and in the second equation, which is beta y2t equal to y1t. Now in the first stage, what we do in the first stage, we will regress y1 on the all predetermined variable. In our example, what we will do, we will regress y1 on the predetermined variables, that is your x1 and x2. And when we regress it y1 on the predetermined variable x1 and x2, then we will get this type of equations. And where you know that in the basic econometrics technique say that when this from pi 0 hat plus pi 1 x1t plus pi 2 hat x2t, this is nothing but your y hat, that is your predicted y value. And we can write that y1t equal to y1 hat plus ut. Okay, what we have done in the first stage, we have just taken that endogenous variables and we run the regression of that endogenous variable on all the exogenous variables, and we have estimated the yt hat. Now we have estimated that instrument variables that can be used in the place of y1t in the equation 2. Now In the our identified equation, in our previous example, see this, in the place of y1t, we have searched and proxy variables which can be fitted or which can be replaced in this place, that is equal to y1t hat plus ut. The over identified equation 2 can be now written as y2t equal to beta 0 plus beta 1 to 1. Now you just see carefully, instead of y1t we have written y1t hat plus u2t plus u2t. Okay, now we with simple mathematical algebraic manipulations, that y2t equal to, finally we reached at beta 20 plus beta 1t plus ut star, that is new error term where ut star is equal to this one. Now when we run the regression of your this, then your estimates here, that is your coefficients, will be unbiased, as well as this is the consistent estimate, and this is the job of your OLS. This is the very simple example I have taken, and in the next few slides I will be demonstrating the real example in the agriculture system by taking the NSSO data. I have shared you that data set. In the second data set, I will be dealing with, or I will be demonstrating you the real example of the NSSO data set. Okay, so for practice, I am just demonstrating very simple things. What is actually done in the 2SLS. So, sorry. Now see, this is the example 2. In example 2, that is y1 is your endogenous, y2 is your endogenous, rest are exogenous. y22 is endogenous, y1 is endogenous, and x3 and x4 are endogenous. Now you see, अब इसमें और इसमें क्या डिफरेंस है? यहाँ पे only 2 exogenous variables था. There were only 2 exogenous variable, x1t and x2t. इसके पास कोई variables नहीं था. But ऐसे भी situations you may face, then यहाँ भी exogenous variables है, यहाँ भी exogenous variables है. तब हम क्या करेंगे? तब हम करेंगे कि y1t को regress करेंगे all predetermined variable, चाहे x1 हो, x2 हो, x3 हो, x4 हो. We have regressed y1t like this and also y2t like this. If this situation you face in your model, then again with the same example, then we will regress y1t equal to y2t hat. यहाँ से हम y2t hat निकाल लेंगे और y2t के जगह पे हम इसके जगह पे हम y1t hat निकाल लेंगे और इसे हम regress कर सकते हैं. You will be more it will be very clear in your next practical session. Now see, in the first data set what I have shared, I have formulated 2 model, that is y1t equal to beta 01 beta 1 y2t plus gamma x1t or gamma 2 x2t plus ut, where y is equal to average annual household income. There y2 is representing average annual household saving and gross annual private investment in agriculture and gross annual public investment in agriculture. This type of model we have formulated based on our economic theory, that, and we suspect that there is a endogeneity problem between y2 and yt, that is saving and income. Of course, you know that the saving is income. Income is also influenced by saving, because saving is investment. At the same time, your saving is also dependent on the income. So we suspected the endogeneity and we regressed, we formulated these 2 models. Now I will go to the starter slide.
What happens, sir?
Here I am trying to share the. Am I slide visible?
No, sir.
Now is it visible?
No,
Stata?
sir. I state are visible, sir.
Now you see, the first thing what we have to do, this is the Stata software I am using for 2SLS technique. So in the first step, you can you can write the steps if you want. I will go very slowly, and if you have any problem, you can stop me there only. The first thing that in the startup, we have to bring our data from our Excel sheet. That is, we have to import our data from the Excel sheet. So what we will do, we will go with the file. We will click on the file. We will go on the import, and the Excel spreadsheet. Now we will here browse. I have saved my data on the desktop on this 2SLS and IAP lecture folder. Now the first data set 2SLS data, I will click and I will open this type of slide we will get. Now what we will do, that is our the first row of any data set is always the variables name. So the import first rows as a variables names. Okay, now it will be okay. Now you can see in your right hand side, there is a list of observation y1, y2, x1 and x2. Okay, now in the first stage, if you remember what I have told you, in the first stage, what we will do, regress. That is the command of regression in the starter. Nothing, very simple. Regress, पहले हमें किसको रिग्रेस करना है, y1 को रिग्रेस करना है किस पे, सारे एक्सप्लेनेटरी वेरिएबल पे. तो वेयर इज अवर रिग्रेस y1 on the explanatory variables, that is your x1 and x2. This is a very simple example. If you regress, then you will get, you have this equation, and now what you have to do, you have to predict. That is, you have to your job is to predict y hat, isn't it? Because हमें y hat को उस पे replace करना है. So predict, we will write predict y hat, and this just enter. Predict y hat, enter. You can see in the right hand side, you have got a fitted value, that is y hat. Okay, now what we will do in the second stage, we will regress. This is the first stage, that is 2-stage least square includes 2 stages. In the first stage, we have to regress your endogenous on all the explanatory variables and get the y hat. And the second stage, use y2. Now you have to regress y2 on your estimated y hat, not y1, because y hat is now acts as the proxy variable for y1. So now when you will regress it, so it will give you the result of your 2-stage least square. This is your y hat is. This is the actual impact of your y1 on the y2. This you can demonstrate, or this you can interpret. This is your actual impact of y1, that is on your dependent variable y2. Now I will again give it another example. Now consider the following model. Now I am moving to the real example in the agriculture, because I hope that you are quite aware with what is the crux of the 2-stage least square. That is, it is nothing. The two things is important. The first thing, the 2-stage least square is in the simultaneous equation model. The 2-stage least square is only applied, or it should be better applied when you suspect or when you find that your one equation is over identified. Number one, when your equation is over identified, you have to go for 2-stage least square. What you have to do, The second is the first, what you regress all your endogenous variables on the explanatory variables, get the predicted value, that is y hat, and in the next step you regress you regress your over-identified equations with your predicted value and get the result. This is the simple crux of the two-stage least square procedure. Now, coming to the another example, you see this is the example. I have written one model, that is y1j equal to alpha 0 alpha 1 x1j. The second is alpha 2 pij plus eij. Now, you may suspect, or based on your economic theory or your previous studies or your published previous literature, that that suggests you that your pij, that is one of your variable, is correlated or endogenous. If you suspect that that is pij, one of your variable, explanatory variable, is endogenous in nature, from your previous studies or your economic theory or knowledge of your economic theory, you suspect that no, pij must be related with yij. You suspect this. So if it is true, then this will be correlated. This will be correlated. Again, you are not able to go for OLS. The simple stage is, and the solution is two-stage least square procedure. Two-stage least square procedure means, now for this pij, what I will do, I will select a number. For this pij, I will be included in this your first model. That is first model, because for example, आप समझ लो कि यदि ये है income of the farmer is dependent on the many of the farm characteristics, and your, that is your training. Suppose NCAP is or any research institute, any your university or organization is on the field level, you are conducting a training program. From 5 years, 6 years, where you are conducting a training program. Now you want to assess what is the impact of this participation on the income of the farmers. So you have written that y1 equal to alpha 0 plus alpha x1. X1 is your age of the farmer, age of the household, education level, etc. And one variable you have written, that is, it is the participation in my training program. Now you suspect that, okay, this participation itself, if you think that income is influenced by participation, but at the same time the participation is influenced by many of the variables, maybe the income. Suppose your participation is with some cost, so maybe the farmers की income यदि होगी तो participate करेगा. You may suspect that. And again, the participation may be influenced by many other variables like age and gender or your education level. So you have written that participation in the training program is again influenced by many of the explanatory variables, and some of the explanatory variables that you think that it may not affect yij. So you have to very carefully define your model. Now there are some zi's, that is some of the variables you have to select that, but not your yij. That here we have to be very, very careful. I will give you the example that pij, you have to define your model such that your pij, your zij, it should affect only your pij, but not yij. That is these variables should affect pij, not yij directly, and it is exogenous variable. It should be not endogenous variables, right? So again, the same step we have to follow. Pij equal to when we will regress this, we will get pi hat ij, and we will replace pi hat in this place, and we will run OLS. This is the simplest step of two-stage least square technique. Now coming to the very practical example, if you are able to see, I have defined I have taken help of one of my friend for that. So I have defined one model that is log net income equal to beta 0 plus beta 1 crop diversification. This is the published paper actually. So that's why I am using this example. And this is actually based on the agriculture based data. And you will connect yourself with this data set. This is the NSSO. This example is based on the NSSO data set. So log net income is regressed as beta 0 plus beta 1 into crop diversification and some of the other variables. Sorry, log net income is defined is regressed at crop diversification and some of the other variables. Now the researcher, based on the previous literature, you see Bellon and Prisla, 2021, so some of the recent literature, they identified that, or they suspect that the crop diversification and the net income is endogenous variable. That is endogeneity between the crop diversification and net income of the households. They have in the previous literature, it has given that the crop diversification and the net income is endogenous variables. So what they did, they regressed crop diversification on the number of other explanatory variables. Now you see the log net income plus this xi is the same: age and gender of household, family member in the working age. This is, in other words, it's called dependency ratio, dummy of ST caste. This data set is belonging to the northeast regions, which has the majority of the ST populations there. So they have taken one variables of ST caste, that is crop cultivation as a principal source of income. This is used as dummy. If yes, equal to 1, 2 equal to no. Land holding, proportion of irrigated area, experienced in crop losses, non-farm income, access to institutional credit and regional dummies. That is 7 states in the northeast. 7 states is there, so they are used that is a dummy variable. Now they have also suspected that your crop diversification is also affected by excise, but at the same time, there are some of the variables which influence crop diversification, like the public extension contact. If the extension contact in the public is more, then definitely the public is going for more diversification process. The participation in the training program है या नहीं है, and market access है या नहीं. If ये facility है तो उन्होंने देखा, suspect किया कि crop diversification को they may affect. So they defined this model. Okay, now they suspected, or they came to know there is endogeneity prevails. So they thought that it will be better to go with 2SLS estimation technique. So they applied for 2SLS. Now, in the starter command, in the first example, I showed you the manual technique, how to regress this and that. But now I will use directly the real starter command, which in one hand give you all the results of 2SLS, and it will be very helpful for you also. We need not to go by step that regress first on this and further on that. So I am using the starter command further directly. So in the first stage, I have to bring the data set on my starter. So I will again, it will be a revision for you. Go to the file, import your Excel spreadsheet. Okay, now I will browse, and I have saved my data in this file, and I will open this file. I will import the first row as a variable's name, and this is okay. Now you will see this type of message from the starter, because we have earlier installed imported other data file. Now the software is telling, if you will click yes, then your previous data will be removed and your new data will be there in your starter. I will click yes. So I have removed the old data, and the new data set is in our starter file. Now see in the right hand side, that is, you can see there is a list of variables that is actually, and you can see your data. You see, if you are able to see, here there is one mistake, that is education. I have taken as a middle, and it should be number always in the software file. It should be always number. Otherwise, if I will regress education, I will take education one new these variables, then there will be some error in the estimation technique, because the start always take the number for estimation, not the this type of words they don't take. And I will check my all the data, and it is very important to see the startup file. If you see any your variable of your interest in the red, that means that the starter is not going to take that variables, that column. So you have to check all these your variables very carefully that you have to use in your modeling. So you see, I have checked all this. My all data set is okay. All are black, and I have knowingly kept it middle below primary to show you that if this type of information comes, then you have to immediately convert your data set in your numeric form, so that it is be able to that the data can use it. Now, the first command, if you want, you can write it also. The first I will give I will give the command after my lecture also, but I want you to just write and do the, which means that if you will face any problem, that we can discuss. IV replace, the command is IV replace to SLS. That is IV regress to SLS. Now the first thing I have to write the dependent variable. My dependent variable is log net income per annum. If you remember our earlier model, IV regress is log in the log form net income per annum. Okay. Now I will write all the explanatory variables. All the explanatory variables, you see that your gender, age 15 to 65 means working age population. Education we can't take. If you take educations, because it is not in numeric form, the starter will not use it. You will find an error. So I will leave it. I will take ST population. If I will take, if cultivation is the primary source of income, you have to just click here. You have nothing, you have no need to write all this. You have to just click here. Your dummy for non-farm income, your proportion of irrigated area, if experienced crop loss, if dummy for, now you see, there are 3 Z variables. The first is public extension, market access, and training. If you remember the last slide, that is, I have listed what are the X variables and what are the Z variables. That Z variables is instrument variables. So I will not use here. I will use it whether there is the need to give the list of instrument. So crop loss ho gaya, extension, agriculture training I have left. Now I have, this is for credit. Now this is the land holding, land total possessed and log of age. Okay, and this is the state of the different states in Northeast, that is state dummy, that Assam, Manipur, Meghalaya, Mizoram, Nagaland, Sikkim, and Tripura. Okay, now the crop diversification. Crop diversification, you might be knowing that crop diversification is measured by, what is the one of the important measurement technique of crop diversification, that is Simpson index. So we have calculated the crop diversification with Simpson index. So I will write the Simpson index, and the crop diversification I have showed you on the slide that the researcher has suspected, based on the previous literature, the researcher has suspected that crop diversification is endogenous. So we are searching the proxy variables for this endogenous variables. To Simpson index, for proxy for this Simpson index is Z. What are the Z's? If you remember, I have categorized 3 values as Z. So we have to categorize accordingly based upon your model. That is your extension training, extension contact, your agriculture training, and the last is your market access. Three variables, 3Z we have defined for instrument variables. So we have to do nothing. We have to just give a command. In one hand, it will give you the estimate of result of two-stage least square technique. You can see here instrument variable 2SLS regression. So this is the coefficient. This is the real coefficient of your 2SLS. Now the common, I will take only 5 to 7 minutes. Now the things the questions may arise in your mind. So whether three questions arises generally in this that is the three type of test you must practice while conducting SLS. The first test is whether really my this variable, that is your crop diversification, that is your based on your theory, you formalized all your formulations and your models, but you really need to test that whether really whether my endogenous, which I have suspected, is really endogenous or not. So for that, I will perform one test, and the command, starter command for that test is estat. That is called test of endogeneity. The test estat, ENDOG. So very simple. Estat, ENDOG, endogeneity, test of endogeneity. And when I will press it, you see the H variable, the null hypothesis of this test is variables are exogenous and your p values is very significant. We reject the null hypothesis and we say that no, what we have suspected was very true. Our crop diversification that we have endogenous, what we have defined, that is Simpson index, was really a endogenous variables in our model. So it was very appropriate to run our 2SLS results. Suppose if you will get this as insignificant, that means to say if this p value is insignificant, there is no use to go for 2SLS, because क्योंकि आप 2SLS का command देंगे तो कुछ ना कुछ तो result आएगा ही. But you must be knowing, or you must have to prove so that कि मैंने जो 2SLS यूज किया है ये सही टेक्निक है. क्यों सही है? क्योंकि देखो आप, क्योंकि आपका डार्विन वाटसन टेस्ट एंड हॉसमैन टेस्ट आपका जो सिग्निफिकेंट है, दैट मींस आपने जो सस्पेक्ट किया, जो आपने थ्योरी पढ़ी और जो आपने मॉडल फॉर्मुलेट किया, इसके अनुसार वो सही में एंडोजेनस वेरिएबल्स था. इसीलिए हमारा our 2SLS result is more appropriate. So the second test is the test of the instrument. This test says that whether the instruments you are selecting for your endogenous variables, like in our case, just give me a minute. Sorry. In our case, we have selected three instruments. The first one is market access, the second is training, and the third one is extension contact. For the diversification, we selected three instruments. Now we have to check that whether the selected instrument is a strong instrument or weak instrument. So for that, for your efficient results or appropriate results, your instrument must be very strong. So we will also conduct a test for that, and the command for that test is estat first stage. Now you see the result. This is the estat, your first stage. Now you see it gives your minimum eigenvalue statistics is 84.67. Now the interpretation is C. If this value, that is the 2SLS, critical values, these are your critical values. If critical values is less than this value, sorry, F value is this one, 84.67. If your critical values is less than your F values, that it means that your instruments are very strong. That is what you have chosen as your instrument variable. It is really strong and you can go with it. Now The third and last test, what you have to perform to check the validity of the instrument. That means to say that your instrument variable, why we have chosen this instrument? Because we suspected that our crop diversification or endogenous variables is correlated with your error term. But at the same time, is there any problem? At the same time, your instrument variable should not be correlated with your error term, and therefore we have to perform test for that. So for that, we will write EST stat OVERID over identification. E stat for over identification, and we will just enter, and it will give you the result. Now you see the null hypothesis in this is the
Dr. Sunil, please mute yourself.
okay. Our null hypothesis in this example is our instruments are valid instrument. Now p-value, based on the p-value, we cannot reject because p is very high. P is not, this is not significant, so we cannot reject our null hypothesis, and we accept our null hypothesis. That is our instrument is very valid instrument. That is, it is not correlated with your error term. So after TwoSLS performing TwoSLS, because when you are going to publish a paper based on your TwoSLS, you have to show the results of this. Unless and until you will show these results, the reviewer may ask you that where are your tests, whether you have tested your instruments are valid, where you are tested there is an endogeneity problem, and whether you are tested that your instruments are weak or strong. So with this test, your TwoSLS technique, your practice or your work is over. Now you can use this result in your writing papers or projects, whatever it is. So this is all from my side on the TwoSLS techniques. And if you have any doubt in the regression part or your lecture part, you can ask. Thank you.
Thank you, sir.
Now, the first, I have one questions in the chat box. The test of ingenuity is for which variable? That is the crop diversification. Test of indigeneity, that what I have told that based on your literature, you suspected that the income, your crop diversification is your endogenous, and the crop diversification is measured by Simpson index. So you are testing the endogeneity for the variables which are endogenous, that we are suspected that it is endogenous. In our case, that endogenous variables is crop diversification, which is measured by Simpson index, जिसको हमने जिस वेरिएबल्स पे हमने डॉग किया था कि ये वेरिएबल्स जो है हमारा y के साथ रिलेटेड हो सकता है, इसीलिए पहले हमें ये टेस्ट करना पड़ेगा ये सही में एंडोजेनस हैवी कि नहीं है, या हम गलत सस्पेक्ट कर रहे हैं। यदि हमने इसीलिए हमें वो एंडोजेनाइटी टेस्ट करना पड़ता है, एंड यदि एंडोजेनाइटी टेस्ट हम पास हो जाते हैं तब हम कह सकते हैं कि नहीं, हमारा TwoSLS यूज करना अप्रोप्रिएट था, अदरवाइज कोई जरूरत नहीं था, हम सिंपल OLS रिग्रेशन से हम उसे रन करके रिजल्ट्स प्रेजेंट कर सकते थे। सो आपको वो टेस्ट करना पड़ता है। यस, नेक्स्ट Dr. Ganga Devi, ma'am, sir, is there any limitation for selection of variables? No, there is no such limitations. There is no such limitation for selections of variables, but at the same time, you must be very careful in the selections of variables. Why? Because I told that your instrument should be valid, your instrument should be strong. So you have to be very. It depends on your modeling ability, that and your theoretical knowledge. what number of variables you are choosing, which is directly related to the endogenous, but not related to your Y variable or dependent variable. Okay. And at the same time, it must not be correlated with your error term. And you, after 2 SLS, when you are performing this test, suppose, and any of your if you will not pass any of your this test, then again you have to change your instrument variables accordingly. Unless and until you pass all the 3 tests, your 2 SLS results will be not efficient estimates or your unbiased estimate. So as such, there is no limitations for the number of instruments. You can select any number. Yes. Yeah. There is no need to write.
You can unshare your screen so that all will be visible. You can unshare your screen, Dr. Vishwa.
Okay, ma'am. Okay, so question was, I'm not able to see that questions.
Box. You can click on chat in between, so the questions will appear.
Okay, then do we need to mention the variables name for? No, you need not to mention the variables name, because you have in the first command we have mentioned the variables name. Simpson index equal to this. In the list of instruments, that is a market access, public extension, contact. So there itself, it is in memory of the software that what you have defined endogenous is Simpson index, that they have taken it itself. So you need not to write again the name of the endogenous variables.
Any more question? Bhaskar, it was a nice presentation. Good.
Sir, thank you, sir.
After a long time, I'm seeing you.
Thank you, sir. Sir, I left NCAP, in 2018.
Yeah.
I am also missing NCAP, sir.
No, we'll call you, don't worry. We'll bring back you.
हाँ सर, वो तो है, लेकिन अभी भी यहाँ भी ठीक है सर. अभी तो जो है सर उसी में चल रही है सर, काम चल रहा है सर यहाँ. I'm exploring the new area of agriculture economics, fodder.
Good.
How are you, sir?
Fine. I hope you also will be fine.
Yes, sir.
Good.
So it seems there are no questions now. Nice lecture of a very difficult topic, which is very essential topic in agricultural economics. So at least he made up the lecture in spite of his ill health due to COVID. So thank you once again.